Right, Jenkins, did you put that 50p in the meter like I told you to? What do you mean you spent it on sherbet fountains?
Jenkins!
Hello and welcome to Tweed's Garage, where in this episode I'm going to carry on overhauling and rebuilding my Villiers 9D engine for my 1939 Excelsior Universal. So, come in. Postman's been, and what's he sent us? So we got the new bearings for the crankshaft, two lip sealed ones and one open, and then what we'll do is pull the lip seal out of one side of each of these two bearings, and then the lip seal will go on the outside of the crankshaft just to make it a bit more gas tight in the crankcases. That's that one, and then one for the gearbox, same thing, it's got a lip seal on it, so just pull out one of the seals, and then when I install the bearing, make sure that the lip seal side goes to the outside of the gearbox case. And again, it's just to make it more oil tight. And then bearings for the clutch plate. They sold them in packs of 30, and I needed 50, so I would have had to buy 2 packs, so 60 in all. And I think it was another £3 on top to buy 500. So I bought 500 because you know, you never know when they might come in handy. And then we got the box. Shall we open the box? Yeah, open the box. Okay, we'll open the box. In the box, we have 2 sets of clutch corks, one to fit and one to spare. New drive sprocket, looking far healthier than the original one. Spare set of points. And there we go, there's the cover for the flywheel and head gasket, and these are these super thin oil seals to do a conversion on the crankcases to make it more oil tight, rather than relying on the bronze bushing. Still put these in, machine these down a bit, and then that will sit on the outside of the case just in front of it like that. So you're relying on the lip seal to provide the gas tightness for the crankcases, rather than a bead of oil round a close fitting bronze bush. And then we've got new piston rings and gudgeon pin. I'll leave that in the bag for now, just so I don't lose it. Van Hill throttle cable kit. Because a couple of the cables are a bit tatty, I think I might get 2 cables out of that, so got one of those. And then in this little baggie we've got new clutch springs, split link for the chain, new sort of thrust washer for the output shaft, or shim. And also in here we've got the new kickstart pawl, screws for the cover on the flywheel, a couple of wood rough keys because the original ones were looking a bit tatty, and a new spring for the kickstart pawl as well. That's that. New seat cover, rather fine. So it's got all the clips riveted to it, so it should just be a case of taking the old one off. Oh, it has actually got padding on it as well, so yeah, take the old one off and then putting this one on. And that should perk it up a bit. New drive chain. and a Bible, so we know what we're doing when we put it back together. Bit of bedtime reading. Yeah, so there we go. No excuses. Time to get on and get it done. Right, let's overhaul the clutch friction plate. Push all these corks out. Quite satisfying. There we go. Clean out the bearing run before I put new ball bearings in. There we go. Right, to the vise. Okay. Failed at the first hurdle, the tab's fallen off. Oh, this is going to be fun. I can see 500 ball bearings going under the bench. Bear with. There we go. Ooh. There we go. There. It's like 52 card pickup. The old ones were definitely worn. These are a bit of a sort of a push fit in that gap that I made, whereas the other ones just fell out. So, job worth doing then. This will keep kids amused for hours. A few more, I think we're nearly there. Oh, I think that's about it. Better just count them. Here we go again. Right. Where's my county stick? Hello. 1, 2, 3.
6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, 18, 19, 20, 21, 22, 23, 24, 25, 26, 27, 28, 29, 30, 31, 32, 33, 34, 35, 36, 37, 38, 39, 41, 42, 43, 44, 45, 46, 47, 48, 49.
50. There we go. All in there. Now just to close up the gap, to stop them falling out. There we go. And put the lid on before we lose the rest of these. So then just pop the corks in. Quite we have to squeeze them in so you don't knock the corners off. There we go. Give them a little squeeze. Said the bishop to the actress. Do you reckon there was a lady called Vera who sat at a bench all day at the factory and sat there popping these corks in? I bet she'd done it faster than this. There we go. One overhauled clutch. Put them so they're roughly in the middle. There we go. Yep, looks good. So before we start putting the engine back together, there's a few little jobs, modifications I want to do to make it, improve it a little bit, make it a bit better. So the first job I need to do is machine the crankcases to take a modern oil seal rather than relying on the phosphor bronze bushings and thick oil, which is the way they used to make the crankcases gas tight. So we'll give them a measure. I think it's meant to be an inch diameter hole that these will be a push fit into, and then we'll start machining the cases. So we'll start with the case that hasn't got the studs mounted in it, because that just makes it easier to mount onto the milling machine. But the first thing to do is clean off the gasket material off the mating faces. So with a nice flat edge, I run it round the mating faces of the crankcases just to scrape off most of the gasket material, and then once that's removed, just go over it gently with some steel wool to remove the last remnants of the gasket. And you can see in a couple of places there's a couple of high spots on the mating faces where obviously it's been dinked from the outside. So the way to deal with that is I've got one of these Japanese whetstones. It's nice and flat. So the idea is to go over lightly with the whetstone and just stone the raised areas until they sit flat again. You can see the raised areas over the rest of the mating surfaces because it's sort of a dull aluminium as you're stoning the top of it, and then you can sort of see when it starts to blend in back into the mating face. So with that done, it's a case of moving it over to the milling machine, set it up on a couple of parallels because there's a gearbox selector shaft that sticks down a bit, so I can't mate it flat onto the milling table. So with that on the parallels, it's just a case of clamping each side down firmly to the milling machine, not, you know, firmly enough not to move, but not too hard that you distort the cases. Then with a centering indicator and with a angled arm on it, so we can get inside, get through the hole that I want to bore, but actually sort of touch the bearing surface behind it, because I want to make sure that the boring is central to the bearing mounting. I use the centre indicator to find the centre of the hole. So you just do that by running the mill slowly, watching the indicator, moving your X and Y handles until gradually the oscillation of the needle gets less and less until you get it to the point that's hardly moving at all. You'll never get it dead nuts in the middle. It'll be, you know, sort of about a thou out. But once that's there, it's just a case of zeroing the X and Y on the digital readout so you don't lose your position. Put in the micro adjustment boring head into the mill and then proceed to bore the hole. I made the depth of the hole a thou deeper than the lip seals, just so it sort of mounts flush and drops down just a little bit. It's not too bad on this side of the crankcase, there's plenty of meat to bore into, but on the other side there's very little left once you bore it out for the seal. The shoulder's quite about half the thickness of the seal that's left, so you don't want to go too mad. And the other thing is, if it's nice and flush, it makes it easier just to be able to pick them out and push a new one in rather than stripping the engine down. So there you go, with a hole finished to size, just in case it's gently pushing the oil seal in, see if it's going to go in, which it does. So with that one done, we can do the same thing on the other case. So as before, clean off the gasket material, tidy it up with wire wool, and then go over with the whetstone just to take down any high spots and move it over to the mill. This side was a bit trickier because it's got the gearbox studs installed in it, and rather than take them out, what I done was again put the crankcase on a parallels, but there was enough room to have the studs hanging over the side of the table, so I didn't need to come up really high. I could mount it at the same height as the previous crankcase. And also on the boring head, I'd marked with a pen my final finished size, so that when I come in again with the boring head, I can literally just sort of run it through until I get to the marked indication on. I know I'm on my finished diameter. So centre it again as before with the centering indicator. Ignore the piece of paper flapping around. That is in there because, as with other things made in China, it didn't work. It's sort of machined off slightly, so you need to put a bit of paper in there to actually make it work. I think I'll have to machine a new holder for the indicator arms, because it's quite a nuisance sticking a bit of paper on. But you're not relying on the accuracy of the gauge too much. You're just using it as a visual indicator of when it's running on centre. So with that on centre again running it on the bearing face, so that the boring is central to the bearing. Find the centre, 0 X and Y so you don't lose your home position, change to the boring head, and bore it out to the finished size and depth as the previous side. Deburr it at the end so it's got a chamfer on it. Pop the seal in just to check it's okay, and then that's that job done. So we can move on to the crankshaft. And the next thing to do is overhaul the crankshaft. This one here, so I've got to put a new big end in it because there's a bit of wear on there, so I need to push this apart. Can't really do it on the hydraulic press because you can support this bit of the crank, but you're pushing down on here, so it's always going to try and tilt like this. So you could sort of try and, you know, clamp this and do that. That may be a possibility, but it's, you know, you've got to have something in this gap here to support this top flywheel half, so you can push this pin down and push this half of the crank apart. When I was looking at the little book that I had, turns back to the audience to annoy the wife, this Bible here, in here, I was having a little look through, bedtime reading, and discovered there is a tool for doing this. So it's this block here. So you bolt the one side of the crank into the block there, and there's a couple of pins there to stop it moving backwards and forwards. And then you wind this bolt in, and it pushes the crank pin out of the this flywheel half. Haven't got a bit of metal this big, but what I have got is a couple of other pieces. What is the idiot doing? What are you doing? Hey, what are you doing? I've got this heavy block of steel here that just gets used as a weight most of the time. It's just a bit of black steel. I've got this piece of heavy tubing, heavy thick wall tubing here. So this is the crankshaft here, and my plan is to bore a hole out here to go over the crankshaft. And another hole here to take a bolt to push the crank pin out. So then that will go, you know, through there like that, up to there. And then with a piece of tubing, that will put the thickness rather than a solid piece of metal. That will bring it up to within access of the nut on the end of the crankshaft. Focusing. So that'll go, that fits quite nicely over there, like that. But what I'll do is, because I think the on the jig it's quite a close fit to this journal on the crankshaft, I'll make this hole just a sliding fit on here, and then on the end of the tube, the other end of the tube, I'll machine up a bit of round bar like this. So have that going on the top, bored out to sit over the tube with a shoulder on so it can't go any further down. Yeah, and then hopefully that'll work like that jig. But it didn't work, there was too much movement on it. So I had to put my thinking cap on, and then the Mark II version come along. So what I done with this was got 2 blocks of steel, drilled 2 holes in them, clearance holes for M8 bolts, and then welded them onto the jig. And then this allowed me to make up a clamping bar that went in the middle of the crankshaft, and the 2 bolts went through and bolted it and clamped that side of the flywheel to the jig. But even with that additional clamp, it was still moving when I was doing up the bolt to try and push out the crank pin. And I was worried that I was going to bend the shaft on the crankshaft on that side. So I decided that as I had a new conrod with bearings and a new crank pin, I'd sacrifice the old crank pin. Didn't want to do it because it's stamped up with Villiers on it, whereas the new one isn't, and I suspect it's the original one, but I had to get it apart. So it wasn't a wasted effort making the crankshaft jig, because it come in handy for clamping the crankshaft in the vise of the mill, ready for machining the crank pin out. So the first thing I've done is centered it using a gauge pin set I've got, so just sort of getting the closest gauge pin that would line up with the rebate in the middle of the crank pin, and then setting it up by eye. With that done, it was a case of running a carbide drill down through the middle to give a bit of clearance for a end mill, and it was quite hard. Once you broke through the case hardening on the outside, it was fairly easy to drill through down into the middle. So using a 16mm end mill would allow me to machine the crank pin out, and it would leave a wall thickness of 14 thou, that's sort of 0.34 of a millimetre. So I started to do that, but just kept my eye on it to make sure it was centred and there was enough wall around the outside that the cutter wouldn't veer off and damage the flywheel on the crank. And yeah, that went really well. And then I sort of went down the full depth of the crank web and withdrew it. And then all I needed to do was just snap the crank, and it broke off the very thin wall that was left. And then it was just a case of just poking it out, and I was left with a perfectly clean, undisturbed crank web ready for pushing the new crank pin in when I come to reassembling it. So then it was just a case of taking the other side into the garage, putting it on the fly press and pressing out the remainder of the crank pin, which, as you see, went really well. So that bench press is really starting to come in handy. Right, that's getting on for over 40 minutes. I know how fidgety you lot get out there, so I think we'll call that a wrap, as they say in the trade. There's only one more little improvement to do, and that is do the welding repair on the kickstart assembly, where the kickstart pull goes in. So I've got to weld that up and grind that to shape, so we'll do that in the next video. But yeah, there you go. Hope they enjoyed that. If you did, give us a little like. If you want to subscribe, just click the little Tweed's Garage thing in the corner there, if it's there. Yeah, and I'll see you next time. Okay, cheerio. Right, Jenkins, you went away with 50p and bought sherbet fountain, right? Right, okay, where's my change? Hello and welcome to Tweed's Garage, where in this episode, dog. But it didn't, excuse me, blah blah blah. Pardon.
Yo voy a cantar esta canción para mi gente.